Hello and good afternoon, CTS265 Section 840 students for the Fall 2015 semester at Anne Arundel Community College. This is the CCNP Route course, and we're taking a look at one of our first Cisco Learning Labs exercises dealing with RIPng. So I'm logged in. We're basically doing the first RIPng exercise, and I've clicked on Procedure here, which we have over to our left. Now you could print this page up if you want to, but these are the Learning Labs exercises are absolutely fantastic because they're going to walk you through, in certain cases, all of the configuration work that you would need to do, and then you're going to transition to the challenge where, and let's see if I can make that a little bigger. There we go. Okay, good. Make this just a little bigger here. You're going to go into a challenge activity where you're then going to take the information that you've learned and apply that to try to finish up a challenge. I apologize, a little housekeeping there. Okay. All right, so let's go ahead and jump in. We're going to configure RIPng, and we're going to be doing it on router 2, it looks like here. And let me slide this over just a little further, try to clean this up a little bit for you. All right, so we're going to be on router 2. So again, this is actually running Cisco's IOL, right, which is iOS on Linux, and you'll also sometimes hear it referred to as IOU, iOS on Unix. But underneath, it's running IOL. All right, so there we go. So now we are on router 2, and let's go from user exec to privilege exec into global config. And remember, it's asking us to turn on IPv6 unicast routing first, because if I were to say IPv6 router RIP, and they want us to call it CCNP_RIP, so we'll stay with that, even though it might end up with some typos at some point in there. It comes back and it tells me IPv6 routing is not enabled. So let's go ahead and make that happen. IPv6 unicast routing. I now come back and start my start the RIPng process, but start the configuration work under the RIPng router configuration area. So let's scoot up a little bit here. IPv6 routing is not enabled. You're going to get an error. So now it says it wants us to do a show IPv6 interface brief. So do show IPv6 interface brief. And for those of you that are kind of maybe new or maybe looking at this material without much experience, when you're in the global config, right, in the global config configuration dialog, in order to run commands, you have to precede it with the word do, D-O, right? Okay, so what do we see here? Well, we see we've got the link local address and the global unicast IPv6 addresses for interface Ethernet 01. And this is also why you only see Ethernet interfaces, because Cisco's IOL and IOU, iOS on Linux, iOS on Unix, only give you the Ethernet speed interfaces. You won't see fast Ethernet, you're not going to see gigabit Ethernet, and you certainly won't see any 100 gig or 40 gig interfaces. And then we've got our loopback address, right? So it looks like we're configured there. So on R2, we're going to enable RIPng on all of those interfaces. So if I were to type in right now and say show IPv6 route, what do we see? Well, we've only got our directly connected and local entries. And what version of iOS is this emulating? Let's take a look here. It looks like it's 15.1, right? So this is emulating 15.1 code. Okay, and you can even see right here, it's the i86 Linux Advanced Enterprise image, right? And it says over here, experimental. But this is phenomenal software. And I can't say enough about the Cisco Learning Labs activities. These are some great activities to really solidify your understanding and to test your understanding of the material to make sure that from a hands-on perspective you have things down. Okay, so we're going to enable step 4, and again, it kind of walks you through here. We're going to enable on those interfaces, so we'll go into global config interface Loopback0 is where we'll start, and I'll say IPv6 RIP CCNP, and remember, I can have up to 4 RIPng processes, running on a router, but I need to make sure that when I enable RIP under the interface, that the name of the RIPng process matches the process which I expect it to be running. So IPv6 RIP CCNP RIP enable, we'll go into interface Ethernet 01 and we'll run that same command again. IPv6 RIP CCNP underscore RIP enable. And so now this is going to enable RIP on two interfaces. And so we just enabled RIP here, and we enabled RIP here. And then we enabled the global RIPng process, and we called it CCNP underscore RIP. Now, we don't know the status of this interface here, and we don't know what's going on over here, but we're about to find out. So let me clear the screen, and we'll transition back here to router 2. So what are some of the commands I can use for validation? Well, I can say show IPv6 RIP database. You can see I don't have anything. If I say show IPv6 RIP next hops, nothing. Show IPv6 protocols. So there's our RIP CCNP RIP process. We've got two interfaces, Ethernet 01 and Loopback0, on which we've enabled the RIPng process with this name, right, under those interfaces there, Ethernet 01 and Loopback0. So we come over here, we did the protocols, we saw that information, we take a look at step 6. It says verify that the IPv6 routing table is showing us routes. Well, is it? So let's say show IPv6 route. See, we're not seeing anything. So let's do this. Let's dig in here. And it's interesting. The exercise kind of walks us through this, but router 1, something might not be as we expect. So let's go to privilege exec and say show IPv6 protocols. And you can see that the RIPng process, CCNP underscore RIP, it's running, and what interfaces is it running on? And this is where the show IPv6 protocols comes in very handy, because I can quickly determine the root cause. And what is the root cause? Well, it's that I'm not running RIP on the interface that is facing, oops, sorry about that, that is facing router 2. So we enabled it here on Ethernet 01, but it looks like there may be something up on Ethernet 03. And I don't know if it showed us, don't remember seeing that here in, maybe I overlooked it. And yeah, I don't see that here. So this may be an area where, you know what, we've got to do a little troubleshooting. We do the show IP protocols and we see right away, hey, it doesn't look like it's running. Let me say do show run section RIP. And yep, it's only on those two interfaces. And we've got our global process configured. So let's go ahead and enable it on interface Ethernet 03 it is. So do show run int Ethernet 03. Let me actually see what is on, and there you go. That might be a problem. So there's absolutely no configuration on Ethernet 03. So if you look at the job aids here, and I'm hoping it doesn't pull away my procedure. Okay, I hope it did not take it away. And this shows us what the addressing is supposed to be, right? So these are the aids to help you, and it's definitely going to help us here. So let's say IPv6, let me click back in here on router 1. IPv6 address, 2001 DB8:0A01, and definitely a little different than the typical ACAD that we normally saw. So let me make sure I got this right here. 2001 DB8:0A01 1400:1/64. Now, if I were to say do show IPv6 interface brief for Ethernet 03, you're going to see we've got the two addresses here. Now, this link local address, right? Clearly EUI 64. There's our FFFE in the middle. However, it's not too much work to go ahead and say IPv6 address FE80::3 link local, and that's what that the LI would have expanded out to link local. So again, makes it a little easier when we take a look at output if we have something in there that maybe means a little something other than that random string of FE80 and then all of those characters, right? So this makes it a little easier. So let's go ahead and do the do show IPv6 now. And there we go. So this is now our link local address, because remember, this is the address that messages are going to be sent and received from between RIPng neighbors. All right, now let's go back whoops, actually we've got one thing left to do. So what do we forget to do? Well, we want to enable RIPng on this interface. So IPv6 RIP CCNP, CCNP underscore RIP enable. Now let's go back to router 2. Let's transition over here to router 2, and let's see if the show IPv6 route gives me some more information, and it does. And that is the same window, unfortunately. Let's see if I can get the back here. Okay, good. All right, so here are the two routes that we should be learning, right? And if you think about it, this makes sense. We're going to learn the Loopback0 address because router 1 has RIPng running on that interface. We're going to learn about the Loopback1 interface because it's enabled there. Why are we not learning the route? And I know if you've watched the previous two videos, you're probably like, please no, don't start talking about administrative distance. But again, critically important. It's going to be a theme that you see throughout the class, even when we start to deal with BGP, where we're going to have routes that are going to be in the routing table with maybe a better administrative distance, and the BGP route doesn't get installed. So here it's the same thing, right? We take a look on router 2, and what does router 2 see this route as? Well, Ethernet 01 on router 2, where are we at here? Right here, directly connected, right? So it sees it as directly connected. What is my administrative distance? 0. So even though RIPng is running on this interface here, when this advertisement, when this advertisement comes over from router 1, you know what? I'm not installing it into router 2's RIB, routing information base. I'm not going to install that into router 2's RIB. Router 2 is going to say, no, I have a more trustworthy source for that specific prefix because it is directly connected to me, and it is 0, the lowest possible value when we talk about administrative distances. However, you know what? You sent me 2 other routes, and I'm very interested in these, and I am going to install those into my routing table. All right, so we see here that those have been entered in. So let's go ahead and clear our screen, and we'll come back here and let's scroll down a little bit. We haven't done anything with Ethernet 00 on router 1 yet, but I think we're getting ready to. So let me make sure it says considers it to be right. And so the hop count, again, very important. Even though it's 1 router hop away, right? When we're talking about the metric, how to calculate the metric for the Loopback0 and for the Loopback1, right? When you look at this, you think, oh, it's 1 hop, right? So you think that's 1. However, the originating router counts himself in the hop count. So it's 1 and then 2 when it reaches here, right? And so that's why you'll see the administrative distance for the routes that router 2 is learning from router 1, they're going to show 2. Because again, it's from, I'm sorry, and actually let me flip this back. It's router 2. I was actually backwards there. In fact, let me clear the screen here. So from router 2's perspective, right, he sees these routes with an administrative distance of 2 because he says, I am the first hop, and this over here to get to router 1 is the second hop. And this is different from RIPv1 and RIPv2, where it was a pure 1 hop, right? It was 1 hop for me to get over here. That was it. With RIPng, remember, the router counts itself and then counts the hop. So it's 1 and then 2. And let me change, I'm not too happy with the blue color there. So it's 1 and then 2. And that's why you see the hop count for these routes as 2. So let's clear the screen. And it looks like we're going to work on some default routing information here. It says, so default information originate and only. Very important, right? I've got the default route that points to the internet. I will use RIPng to tell R2 about it. So there's 2 ways that we can do this. And I'm going to leave the screen right here. There's 2 ways that we can do this from router 1's perspective. And again, this cannot be done on a per interface basis. Let me, or I'm sorry, it is done on the per interface basis. So if I say and I'm in Ethernet 03. I want to tell router 2, hey, I've got a default route. Here it is. And this is how you're going to get to it. So I would go into interface Ethernet 03 and say IPv6 RIP CCMP _ RIP. And that's where we find the default information command. Now, I've got two options. I've got only and originate. If I say originate, which is what they're asking for here, I'm going to continue to advertise from router 1 over to router 2 all of the routing information that I've already given him, and in addition to that, a default route. So let's take a look at that. Default information originate, and I apologize there, that was the previous video that was being exported out. So default information originate, and we'll hit enter here. Now let's step back over to router 2, and let's take a look at the routing table now and see if it looks any different. And it does, because what do we see now? Whereas before, and this actually worked out kind of nice, and this is a little small, I apologize. So as before, we had only the 2 RIP routes. Now we have a third RIP route. And the third RIP route is our IPv6 default route : /0. Again, same administrative distance and same metric because it is 2 hops away from the RIPng perspective. So now we have this default route, but the key here is I'm still getting the other 2 more specific routes. So if I was, for whatever reason, if I'm trying to do, traffic manipulation with longest match routing, and I don't want to just throw a default route in there, that could be one reason why I do default information originate. Another reason could be, you know what, sure, let's go ahead and say that this guy is a stub, right? Maybe he's your remote office somewhere in San Francisco. And he's only going to get these 3 routes. And this may be, let's say this is going across a T1 for whatever reason. This, right, 3 advertisements, this is minimal overhead, not a big deal, right? And so, okay, maybe it makes sense to do this. If this is like 200 routes or 300 or however many routes that you're trying to advertise back and forth, maybe that's a problem. And now we're going to take a look at the default information only to make it a pure stub scenario here. So let's clear the screen. And let's go ahead and scroll down a little bit here. So that's the default information originate. I still see the other RIP routes that are being advertised. Now, let's change it up. Let's say that management has decided that we're going to downgrade that T1 link to 56K, and you decide, hey, I've got 100 other routes that I need to push over to that site. Well, you know what? Do we really need to do that? Let's make it a pure stub here. And when we start to look at the EIGRP in Chapter 2, we're going to look at the EIGRP stub functionality. We're going to look with OSPF at the stub areas, the totally stubby, the totally not so stubby, and so forth. So let's go ahead on router 1, do show run in Ethernet, oops, sorry about that, interface Ethernet 03. And we're going to go ahead and say no IPv6 RIP CCMP _ RIP default information originate. So we're going to pull that out. Now remember, what's going to happen? Is it gone over here on router 2? No. So I've pulled that off of router 1. However, it's still here on router 2. So remember, if I were to say show IPv6 RIP CCMP _ RIP database, and we're going to see a little difference here in about, and there it is, about 2 seconds. So what happened? Well, the 3 routes in the database, right, all refreshed and went from 150 back up to 180, right? And the difference between 150 and 180 is 30. There's your 30 seconds right there, right? So a new update came in. However, what did not show up in that update? Because this guy here is at 149, and now he's kind of on his descent, the countdown to extinction, so to speak, of where he is going to disappear. Now, he's in the database, and he's going to sit in this database for 3 minutes. Then the garbage collection is going to kick in. He's going to sit in the database for another 120 seconds, so 5 minutes total. Where he won't be for all 5 minutes is in the routing table. So it's still in the routing table, right? And it'll sit here for 3 minutes. And then at the end of 3 minutes, it's going to go away. Now, we've already seen this. So I'm going to go ahead and I'm going to force the clearing. So I'm going to go ahead and say, do it on both. So clear IPv6. I believe it's router RIP, or it's RIP in the process name. Let's take a look here. Yeah, there we go. CCMP_RIP. So I'm going to force a clearing of the process. So now let's see what the routing table looks like. Well, now we've got nothing, right? We're going to give it some time here, probably close to, and there we go. And we've now we've cleared the process. So what's my database look like? Exactly. So basically we forced RIP to update. Now that is a command in a production environment that you do not want to run. You want to allow RIP to take its time and to do its thing, the 180-second hold down, I'm sorry, not hold down, I apologize, the 180-second expiration time, and then the garbage collection time, which again you can see with the show IPv6 RIP, right? So our expiration time is 180 seconds, which we see right over here, and after 180 seconds, and then here's my garbage collect, right? So if I don't want to wait what is going to be the equivalent of 5 minutes, 3 minutes in the routing table, and another 2 minutes in the database, and this is the RIB, routing information base. If I don't want to wait that time, I can run the command that I just ran there, which was clear IPv6 RIP, and the name of the process, and let me make sure that I'm correct there. It was, make sure I gave you the right command. I thought I ran it right in there. I don't see it in there. So yeah, it would have been clear IPv6 RIP, not a command that I run. Yeah, clear IPv6 and then RIP and then the name of the process. And that will force RIP to refresh, right? So now, what are we going to do now? Well, let's go back to our use case. We're going to go ahead and say that router 2 only needs a default route out, right? That's it. We're not going to be sending all these other updates to them. So what's the other option? Only. Right? So I'm going to say no, or not no, let's pull this back here. We're going to say IPv6 RIP, CCMP RIP, default information only. And what that means is I want router 2 to only receive from me the default route. Now, it's not here. Why is it not here yet? Well, we're going to wait. We have to wait for the update. So we'll give it a second here. And actually, let me step over to router 1 and say do show IPv6, do show IPv6 route. So we are still learning that route from router 1 right here. I'm sorry, from router 2. So let's step back over to router 2 where we should see, there we go. But the other entries are still there. Why are they there? Well, if we do show IPv6 RIP database, you can see why. Because RIP is going to wait for those to expire, right? 180 seconds in the routing table, it's going to sit there. That's your expiration time. 3 minutes, and they will sit there. Let's take a look and see what the advertisements look like. So if I say debug IPv6 RIP, and I apologize, this text is a little small. This is about as large as I could get it. Without making some additional changes. So we've got our debug on. Let's see, we should be receiving the debugs, and we are, and I'm looking for on router 2, so we're receiving from router 3. You can see that the updates are showing what? There's only one route table entry. There's only one RTE, and we'll kill the debug. There's only one RTE coming in, one routing table entry, and what is that? You've got it. It is our default route, right? That's all we're receiving. And again, the source is router 3, and it's out, or it's coming in on Ethernet 01. Actually, let me mouse over. That should be correct. Yeah, because Ethernet 03 is what we enabled on router 1. So it's coming inbound on Ethernet 01. That's the interface we're learning it on from that neighbor. And there is the IPv6 RIPng multicast advertisement address, FF02::9. And again, it's only advertising this. We're only receiving that advertisement. If you take a look here, right, this is what we are sending. So this is our advertisement. And again, very important when you look at this, you're saying to yourself, well, wait a minute, split horizons in effect. Why is it advertising all these routes, including the default route? Well, it's because it's going out to the loopback interface. It's not going back out Ethernet 0.1. It's going out the loopback interface. So therefore, split horizon, for things that have been learned from router 3, when it's going out a different interface, not the same one it was learned on, it will send those advertisements out. And so that's where you can see here the source port, the destination port information. And where are we at here? There we go. And those advertisements, or those prefixes. All right. So really what this was to do was to kind of walk you through the default information only, the default information originate. We looked at how to clear some things. But again, we now on R2 show IPv6 route, we are now only getting the default route. And so that kind of, again, when we come back up here, I apologize, went by a little fast there. When we come back here to the original drawing, what we're saying is, hey, router 2, we're going to make router 2 a full-blown stub, right? And he is only going to get a default route because that's all he needs. Because how many ways can router 2 get off of his segment? One, right there. So why not send him a default route? It shrinks the routing table. It shrinks the size of the updates that router 2 is going to be receiving. And again, if he only needs the default route out, then that's what we'll supply him with. Again, you maybe say this is your branch office here, right? All right, well, this wraps up the RIPng Cisco Learning Labs first activity for RIP. And so if I were to clear my screen and pull this out a little bit, remember that your time is running, right? So you want to make sure that when you're done, you exit out, and I am going to go back to the main screen here, right? And now my time has stopped, because remember, you're only allocated 3,000 minutes, so make sure you use that wisely. So don't leave yourself logged in a lab overnight and then get up and go to work and find out that you've just used 12 hours of your time. Okay, so this was, again, Discovery 1, configuring RIPng. Our next activity is going to be the challenge number 1, where we're going to take a look at configuring RIPng, and it's going to be, and again, they call it the challenge. It's going to be a little more challenging, where they're not actually providing us every single command that needs to be run. All right. Thanks for watching, and I will see you guys on Monday night.